First thing I noticed with this switch mode was all the capacitors in the output stage were ruptured, so I went ahead, changed all them out, but this didn't bring it back to life. It was still dead. So I think generally the first thing to check on a dead switch mode is the hot rail. It should be right there. So yeah, that's about right. It's over 300 volts. It's quite easy to see that. Just check across the capacitor one, the main smoothing can there. So that proves all that's working anyway. Some people have reported that it's blowing fuses on theirs. If that's the case, check Q4, the MOSFET may have gone short. Don't just keep changing fuses and blowing them up, because you're probably going to end up doing more damage. But fortunately in mine it hadn't failed, so I moved on to the visual inspection. But I did notice that resistor R65, that looked like it had been getting rather stressed. It was cooked. It hadn't actually gone open circuit. Should have been 5.1 ohm. I was seeing about 10-11 ohms. It had gone up in value, to clearly pass too much current by the looks of things. So okay, I moved on, see what it fed. It feeds Q7, the transistor down here, with ZD4. Q7 had gone dead short, collector emitter dead short. The Zener, that had turned into a resistor. I was seeing about 150 ohms both directions, so something was not right. So I went ahead, changed the resistor out, changed the transistor and the Zener, and then tried to fire up again. Now what should happen, pin 1 here should develop a voltage across this capacitor at startup. See, the mains comes in off the hot rail to pin 8 on the drain with respect to ground pin 2. That tells the chip that you want it to start up. So what it will do, it will produce a small voltage at pin 1 VCC, and it will charge this capacitor up. When it hits 4 volts, it will then go for a startup attempt. Obviously then it can power this auxiliary winding up here, and then that in turn powers all the chips. That brings voltage up to all of them. But when the one I had, it wasn't doing anything. I mean, it was producing the voltage at drain and ground, and what I was seeing at VCC was nothing. A nice convenient place to check the voltage at the VCC is on the board. Pin 4, IC4, nice convenient place. And that, I will zoom you in. Right, you can see it really. That's there. So, pin 4, IC4, we're getting about 14 volts, that's about right. And what I was seeing before was nothing. So if you're getting nothing, you're probably going to have to change IC2 like I did. So that was okay. Let's see. Now what was happening when I changed the chip, the voltage was actually attempting to develop across this pin 1. It was trying, but something was dragging it down clearly. So what I found, Q11 there at the startup transistor, and Q9 that had developed a severe leak. So of course IC3 and IC1 was just sapping the voltage away from pin 1, so it was unable to ever reach 4 volts, its startup voltage. So what I did, I disconnected the collector of Q11 and tried starting up again. That time the voltage developed and it started up, and I got nice 5 volts appeared, so I was starting to get somewhere. So then I went ahead, changed Q11, Q9, changed them out, and then this time I pressed the power button, red standby light, it actually went green, but the 24 volt and the 12 volt rail didn't come to life, they remained at naught. Now the reason the green light comes on is because this MOSFET is being turned on. You can see it's a bit awkward this. That's actually running off the 5 volt rail. The motherboard will latch something to keep that MOSFET turned on, and that's what sends the light green. So regardless of 24 and 12 volt rail, the light can still go green. Right, so that turns on the opto coupler here, turns on the startup transistor, which in turn turns IC3 and IC1 on. So power factor correction and power controller there. Now what was happening, it came on, but then it started to make funny crackly noises. I don't know, it was clearly something was not happy. So what I did at that point, to break jumper 13 there, which is, if we look on the board, that's it there, jumper 13, that one, broke that, put the meter in circuit, measured the current consumption. Now it should be no more than 25 milliamps that IC1 should draw. And what was happening, I was seeing, well, it started off at about 65 milliamps, that slowly increased to about 100 milliamps, in which case it started crackling, so I did shut it off because I didn't want to do any more damage. So it became clear that IC1 needed replacing at that point. So what you should see, if it's running, I'm going to go turn the thing on. Okay, it's come on. So jumper 13, you should actually be seeing that internal rail voltage 14 volts. It's about right, that is. Sorry. Oh, this is awkward. And that's what you should be seeing. If it's dragging down, it's 9, 8, 7 volts or something, you're probably going to need to go ahead and change IC1. Okay, so that's cleared it. And another thing, what I did do, I don't know if I'm going to get in that close. Let's see. Oh, there we go. Alright, that's now Q7. I've mounted it up on top deck because there was room to do it, and instead of using the one that they did, which is half amp rated, the one I've used is actually a BC635. It's rated, it's got a 1 amp collector current, that has. So hopefully if it happens again it won't blow them up. Same with the other transistors, Q11 and Q9 PMPs I've replaced with, they've got 1 amp collector current as well. There is ZD4, the Zenat, 1.3 watt instead of the 500 milliwatt one they gave it, so I replaced that. Be careful what you're doing with this because you're at half mains potential. Most of the heat sinks on this, so well, not quite, but of course it's running now. Drop it, doesn't it? Yeah. So as you can see, okay, it's going to standby now, but if you touch the casing with respect to the heat sinks, you are going to see voltage, so be careful what you're doing because this is all mains potential stuff. So okay, I think that's it there. Shut that off. Well, that's it. It's been running now on soak for about 9-10 hours. Been no ill effects. So should be okay now, hopefully. So just a recap, you're going to have to go ahead and change the capacitors in the output, all the electrolytics that failed. I'm going to recap that. Then check, where are we? R65 should be around 5.1 ohms. It's not a critical value. I mean, I replaced with I think it was about 5.8, something like that, just because that's what I had. But as long as it's a few ohms, should be okay. Replace Q7 and ZD4. Then check continuity between pin 8 and the hot rail, just to ensure that it's appearing at pin 8. Pin 1, as I showed, you should be developing a voltage there, and it will have to go above 4 volts. Check Q11, the startup transistor, that may have failed. Q9, same again, check that. And then when it's up and running, if you're not getting 12 and 24, measure the rail here, what's appearing at capacitor 31 on jumper 13, and if it is pulling down quite dramatically, the voltage, then you're probably going to have to change IC1. So I'll just run it for a bit longer and then see how it goes, and hopefully that'll be okay.